Welcome back, and now we're going to look at some more examples related to double angle, half angle, and power reducing formulas. So here's our first example. You can go ahead and pause the video, try it out, and when you're ready to resume the video, you sure can. And there's another problem down on the screen, so try that one out as well. Resume when you're ready. And here we go. So first thing I did was I drew a picture of where cosine of or sine of theta would be, and then introduced the sine angle. So we know it's quadrant 4, so then sine is minus 5, which is the y, over 13 in the hypotenuse. Horizontal component is 12 due to quadrant 4. But so then theta being in quadrant 2 or 4 means that theta over 2 is in quadrant 2. Okay, and that's the quadrant where we need to use to determine whether it's plus or minus in front of the square roots for each of these half angle identities. So for sine of theta over 2, just use the formula, square root of 1 minus cosine theta all over 2, and then I chose the plus because sine is positive in quadrant 2. So then evaluating, I just left it as this. I didn't bother doing the division and further simplification. You can if you so desire. Okay. Similarly for cosine and tangent. So just review your answers in comparison to mine, knowing that I did not fully simplify. For the second one, a lot of patience with this one. First thing you have to do is recognize that 3x is the same as 2x plus x, and then use cosine angle addition. So this is angle addition. So we're combining multiple skills, and then from there I took the 2x I did the double angle for cosine and the double angle for sine, right? Got those in those forms, and then from the second line here to third line, I just simplified and simplified some more. Okay, and then in this third to last line, I took sine squared and wrote it as 1 minus cosine squared via the Pythagorean identity. Okay, and then distributed and collected terms and got my answer. Okay, so that was a fun one. The last one can be a little challenging at first glance. You're like, oh my god, there's cosine and arcsine. Oh my gosh, what is going on? Big thing is not to panic, because this is really just the same as saying cosine of 2 theta. Well, okay, we know how to find cosine of 2 theta, right? We know the double angle for that. So we can use that formula. We can say that this is the same as, so cosine 2 theta, this is the same as, well, we can maybe try this identity, 1 minus sine squared of theta, right? So we can say that this is the same as 1 minus sine squared of arcsine of 4/5, right? We can try that one, okay? And now really, the sine squared, you might recall, this is the same as saying we take sine of and then arcsine 4/5 and square that. Okay, and so here there really isn't that much work to do, because sine and arcsine can cancel out if they're inverses. Granted, we have to be in the right domain and everything, and this version is okay. But we end up with 1 minus and then 4/5, right, because those end up canceling out, squared. And so then 1 minus 16 over 25, which is the same as 9 over 25, assuming my calculations are correct. Okay, so big idea on this one was just to use that double angle identity. Alright, so that really wraps up this section. We've got practice with angle addition and difference, double angle, half angle, and power reducing formulas. So make sure to have all those written down and handy so that you can be successful in future quizzes.